presentation from Taran Singh, who has worked for last 2 months with us in AAIE specialization. And he has been, this is his Hive project where he has used machine learning, deep learning architecture to detect breast cancer cell which has which is benign or which is infected. So here he will talk about his this project. Also, this is his final year project in his university. He is a third year, he's a fourth year student. So this has also been presented in his college. And Karan, you can go ahead and start your presentation.
Okay. Hello, sir. Nice to meet you. So basically, sir, my presentation is on breast cancer detection. It's an a DL method. Using DL methods, we used to classify the image task and how to detect the malignant and non-malignant detections. So before starting this presentation, I would like to thanks to Vishal sir that he helped me to connect with this AI project. And later then I got connected with Anishta ma'am for helping me and through guiding this whole project from the beginning to the last. So this is my presentation on breast cancer detection. So we're gonna discuss how it's gonna work all and how it's gonna working back end and front end all we're gonna talk in this presentation. So getting forward to this slide, we have the first slide after how is the overview of the like what is breast cancer detection and how far it has been engaged in the medical analysis and automated diagnosis. So we have overcome about many cancer detection, but we also know that AI has also improved many detection while reducing the false negative and many necessary biopics and patient outcomes. So the main reason we are doing this presentation to just identify the malignant and benign images, whether it is spreading all over the images or not. So we are defining each and every images of this in this presentation and in this project. So beginning with the overview, like we are using the DL methods like CNN, convolutional neural networks, which is widely used for image classification task and of course for the brain tumors and breast benign tumors also. So about the technology, we are using the DL methods and the many augmented data sets we are also using to improve the accuracy from getting not getting too much of that, but also for better patient outcomes also. So we are also here that we are also started with the AI and we have also getting into many innovative ways also in the healthcare centers. Like we are combining the AI and we are for enhanced detection and improving the both accuracy and the breast cancer detection to all over the globe as well as. So this is a technology which we are using and
Hmm.
getting into the next slide. We are having the architecture. Before that, we were using BG16. It was a 16 layer, but we had to improve the accuracy, increase the data set. So that's why we are using the ResNet 50 architecture, which is a 50 layer convolutional network, and it is also widely used for medical analysis for mainly for image classification task. And it's a 7 into 7 padding. Like before that, VG16 is 3 into 3. This is 7 into 7 convolution layer. Like we are reducing the in every convolution, we are reducing the dimensions of the images, and we are getting like 3 kernel padding and 3 kernel size and 1 padding. So on the right hand picture, we can look that there is 3 into 3 dimensional images, which getting converted into 7 to 7, and it is getting into 3 into 3. Like we are reducing the size of the dimensions, and we are getting as far as the image to detect clearly. That's why using this architecture for the presentation we are here for the working procedure also. So this is the architecture we used in this project. And moving on to next, we are on the data augmentation. Of course, we don't have many data sets to improve the better detection and accuracy. So that's why we use the augmented data set. We all know that widely used for getting number of images from one getting images. Like in the left image size, we can see that from the one image we are getting number of images to increase the accuracy and the detection performance as well as. So mostly in the malignant cases, we are using the data augmentation. As far as widely from my knowledge, I think it's the best starting initial stage, like we can detect the accuracy more far as up to percentage, like from the data augmentation. So that's why we are using the augmented data sets to increase the amount of training data and also to enhance the breast cancer detection in this way. So this is the augmentation data sets we used. And moving on to next slide, we are using the optimizer, which is very well being known in breast cancer detection. It's generally used to generalize better and ensuring stable models to the breast cancer detections, and widely used to accelerate the training and many suitable for deep learning tasks also. And it is practically be used significantly to building both accurate and practical for the clinical use also. Like from this optimizer, we can vary that we can optimizing the weights in such a way in such accuracy, like we can get the accuracy as much as possible we need to find out from this project. So that's why using the Adam optimizer over here. And right side we have the graph also, like from the zero point 0.2 it's how it's working to getting from negative to positive. We on the graph you can see. So this is a function as the optimization part also, like the number of data set is having, we are using the Adam optimizer to check to adapt the learning rates and diversely can suitable for deep learning task only. And moving on to next slide, we are using the loss criterion. This is that how we train the data, like loss criterion is also used in to predict the models before and after the malignant conditions. So it also evaluates the loss function between the predicted model and the actual model outcome. We can predict and we can improve the model by minimizing the error, which can enhances the accuracy of detecting breast cancer. And it is also important because it is very sensitive while it can detect cancer while it is present, or also can detect cancer while it is not present. So that's why we use loss criterion over here
Yeah.
for to predict a well predictive model, especially in machine learning and AI applications as well as. So this is left side we have the code over the of the loss criterion. We have also used the cross entropy also to detect also. And like we have the loss equal to criterion, we have used the output labels. Then we have the running loss plus we is checking like how many it can take the errors between the actual and the predicted outcomes of the data set. So we have the code over there. So that's why it is important to ensure that we can balance the errors to ensure that model is sensitive or not, we can find out from this loss
Yeah.
criterion. So moving on to next slide, like this whole we how we can predict the data. And after all, after doing all these methods, now we have to train the data. Like how we gonna train the data, like how we gonna split the data into three terms. Like in the left slide I have the data splitting. Like first we have the training set, we have the validation set, we have the test set. So of course after having a training set we have to take the training size of course to 80 to 70% for getting more accuracy. Like in the right side last image we can see like the training size is zero point 0.8, like we have taken 80% 70% for training and 50% validation and 50% for testing to get the more accuracy as well as possible. So we have to divide these sets into three, like training, validation, and test set. So we have creating or we have also created a data loader. Like in the image we can see this trained data loader which has a batch size of 32 and val loader which has batch size of 32. And after that we are printing the training data set and validation set size using the augmented data set also to see if we are taking zero point 0.8 accuracy 80% training set, that how much we can get accuracy as well as. So this is how we train the data from the data loader, from data set, then we have to train, then we have to validate, then we have to test. So this is how the testing occurs in breast cancer detection in many real methods also. So on the next slide These are the final results. These are the number of epochs we have used. So the epoch requirement may be 50, maybe 100, but we have run these project for 25 epochs, and on the image we can see that we are getting the accuracy of like 99.71%, and val loss is 0.3, and val accuracy is 92%. That's a pretty good score for our project. We have the graphs over all the epochs and training accuracy. And so for
Mm-hmm.
example, uh, if we take 10 epochs or 5 epochs, might we not get the much accuracy, but of course if I can take 50 epochs, I will getting more accuracy. But for sure, for taking 25 epochs, we are getting 99% 0.71 accuracy using the augmented data sets also. So it's a pretty good score for our project to determine that we can have the accuracy up to 90 plus percent in the most cases. So we have used the epochs after getting training the data validation and validation data set. Use the epochs to find out the accuracy, that how much our model is getting the accuracy, validation loss, and validation uh, accuracy as well as. So this is the report where we got the final results on the whole epoch accuracy. So
Mm-hmm.
this is the backend of our main project, and we have also done the front end, that how you gonna predict the image. So on the next slide, this is the integration front end and back end. The front end in which we have used the JS node, JavaScript, where we have JS.node we have used. Backend, the virtual machines we have used Fast API and Docker. A virtual machine we have used to create the models, to create the predict the models of the images, whether they are working or not, or whether they're getting to predict the models or not. So this is the front end and back end integration of the image. We can see like how it's work with the whole system. And this is a video of the front end, how it's gonna work. Make sure it's gonna be good, and we can see how
Mm.
it's gonna see the accuracy and predict the model. So you can watch this video, and which will be pretty well. We are using a Docker as a virtual machine.
Mm-hmm.
So now we have to start the Docker from the Fast API. And this is a front end which we are using the JS.node, and we wanna check through the local port whether it is predicting or not. So we've got a login page where a user can log in with his password and with his details,
Mm-hmm.
just to make sure that the front end is working well. And we log in, and this is a main page, just to check whether it is working or not. You can choose a file, pick, and the prediction results is benign, like it's not malignant, like it is not a cancer. So this is how the front end is working, and we can predict the images with the 90 plus 90% accuracy, whether it is malignant or not. Uh, so this is how our front end works. And before that, I've explained the back end, like how we have trained the data and as well as what we're using and which architecture and all. So for front end, we have used JS, Node, JavaScript, and PyTorch
Mm-hmm.
also Python. With programming, we have coding. We are used so PyTorch also fast API, and the virtual machine we are using is Docker Desktop, which is a far better virtual machine where we are hosting a local host over there, and we can seeing that it's working or not.
Yeah.
So this is the front end, and it's worked well, and this is how the whole project works. And at last, this is my GitHub repository, and we can check over all the files, all the codes over there mentioned over there. And
Mm.
this is how project works, how whole. And
Okay.
I hope,
Very good. Very good.
I hope you gonna, you liked my project, and make sure this is my, of course, this is my first presentation in my, like I'm in fourth year, and this is my final project as well as, and of course I'm very grateful that I am presenting this project in AI platform,
Very
live
good.
AI platform
I have two
also.
questions, Tarandeep, for you. Can
Yes,
you
sure, sir.
open your presentation slides?
Yeah, sure, sir.
Okay, here, stop, stop. Yeah, no,
Okay,
this one. Yeah. So we'll be here first, and then maybe you'll have to go back to explain some things to me. So as you can
sure,
see
sir.
here, there is, well, I would say, I wouldn't say significant, but a reasonable gap between the training and the test validation accuracy, right? So
Yes, sir.
about, I would say, 10%. And
Yes,
in the
sir.
loss as well, the loss is not smoothening. So what I think, what I would want you to explain to me now, at least theoretically, is
Yes, sir.
what did you do to reduce the gap? So I mean, ideally that's where the successful algorithm versus a less successful algorithms are differentiated. What techniques did you try to reduce the gap? Because if you see, if you just look at the first epoch, um,
Yes, sir.
or the second epoch, you're seeing that the validation accuracy is very poor, then it starts increasing. But
Yes,
ideally, in a real world and a successful scenario, the uh, validation and the training accuracies tend to converge quite close to each other. For example, you see that, let's say in the first epoch already, the training shoots up to 96%, if I can see here. And
mm,
ideal situation should be that the validation should try to aim for something higher mark. But then in the eighth epoch, roughly, you see that the gap between the training and the validation is around, let's say, 98 and 87. So it's about 12%.
yeah, 12%. Like it's between
Oh yeah,
every time the
11%.
training
But
accuracy
it's,
is, yeah,
yeah,
between.
yeah. So my question to you is, what techniques did you use to try to at least tackle the situation that both the curves, one, converge, are less jittery, and what did you try that? You can
Of
see the
course,
jitter in the
yes,
curve. For example, let's say if you would have run 1,000 epochs, probably
yes,
you
sir.
could have smoothened. You can smoothen the layer. That's possible. You could have done that, but that's just a cosmetic exercise.
Yes, sir.
Cosmetically, you can apply a simple smooth function, and then it just smoothens the layer. But that's lying to actually the system and also
Mm,
perhaps to the recipient of the solution, because it's not sort of consistent. So natural smoothing is important because it shows that your model is so sophisticated, its algorithms in the kernel have been rigorously tested, and that's when you can You can also demonstrate your theoretical background around reducing the gap and having a naturally smooth sort of curves. So
Yes.
can you show me a slide before what are the techniques you did? What did
Yes,
you
sir, sure.
experiment?
Yes, sure. So, uh, we have used the loss criterion, which minimize the error, and actually it also helps to increase the accuracy as well as. And the main function we have used, which is Adam optimizer, and the architecture which we have used like before data augmentation is Resonance 50 architecture. So before
Did you
that we are
try?
using
Did you
VGC60.
try? Did you try 18 or 151 and ResNet 200 plus architectures
Uh,
as well?
Before Resonance 50, we tried VGC16, but the score
Mm-hmm.
was pretty bad. Like we are getting like 60, 65 accuracy, like in 30, 40 epochs. So we're
Okay.
not getting much accuracy and we're not getting much smoothing in the graph also. So after that, we use Resonance 50 architecture. And of course, we've run
Mm-hmm.
only for 25 epochs. Maybe the
Yeah,
graph
yeah,
is not too smoothing, but I guess if we run for like 50, 60 epochs, maybe the graph can make a little less gap than before.
yeah,
And it
yeah.
would
And you
be better for,
probably also tried hyperparameter tuning, right?
yes, sir,
Exactly.
Initially.
hyperparameter
What
tune.
did you do? What
Yes.
did you do with hyperparameter tuning? What did you tweak around? What did you play around with? What value did they give to the dropout? Did you try other techniques
Uh, we
like in
tried,
pooling? Did you try
yes,
to
sir,
do
we have,
different forms of pooling, max, or did you try stochastic? Did you try
no, we
average?
tried
What did you
maxed pooling,
experiment?
and we
Yeah.
experiment max pooling. And
Uh-huh.
the main reason we are getting this accuracy is just because of, I think, using this Resonance 50 architecture and Adam optimizer and the loss criterion also. And I guess previously, which I was using VGG16 with the same max pooling, and it was a combination layer of 3 into 3, but we're getting poor bad score of that graph also. And while running to 40, 50 epochs, we are just getting like
Okay.
56, like 60, and the gap is far away, like 20 to 25% is between the validation and training accuracy. The gaps were
Yeah.
more than before.
Did you
So
try any
just
other
to,
architectures besides
right now we are,
VGG, ResNet?
no, right now, but we only tried this two, just to make
Okay.
sure that we are getting little bit minimum epochs, we can getting at least, we can get at least 80 to 90% accuracy. And
Hmm.
I make sure like if we run for maybe for 50 epochs, maybe the graph will be little more smoothing as well as, I guess so. And
Yeah.
it will
Okay.
yeah, the gap will be maintained in that accuracy.
Yeah. Okay. I think the front end as well is just an advice. So let me just try to give you some more advice slash
Sure,
suggestions
sir.
because, of course, I think
Sure,
it's a
sir.
good attempt. It's your first project, as you mentioned. So I think right out of the gate, when you take the best practices that are there, your second project can become far more sophisticated. This is a great
Mm.
start, so which is a good thing. For example, my advice number one would be is to
Yes, sir.
understand. See, when you say because VGG16 had was a older model, older architecture, ResNet 15 was popular sometime in 2018, 2019. So one thing you should know is just don't blindly start looking. But there are many models, for example, many architectures. There are, for example, there is an architecture called MobileNet.
Mm.
There are combinations of architectures as well. You can add architectures, stack them on top of each other. Those are the things you can only learn when you practice. Because, for example, you can add ResNet on top of MobileNet, or there are different techniques to do that. It's just a basically simple
Mm.
addition, actually, operator. In actually, when you say okay, choose this model, you can say choose this plus this model. That's one. Experimentation and trying to experiment different things is key.
Mm.
Second, No amount of experimentation can really save you, because amount of data, the amount of quality of data is always is the defining factor of your success. So you can experiment. That's good, because you can. That's for you to figure out how can I get the better results. Going back into the value chain, it's very good to think, okay, I have 10,000 images versus 50,000
Mm.
versus 100,000. What can I do to do sort of augmentation of those images to actually further go deeper? You can slice an image, as well, create more samples. So then what will happen is, instead of having 10,000, you will have 100,000 or 500,000 samples. Split
Yes,
those
sir.
into test, train, and validation. Sometimes people also use development, test, train, develop, and validate.
Mm.
Test,
Mm.
train,
Uh,
test,
Train,
and
test, and
validate,
validate.
and
Yeah.
also development. That's a good technique to do that. Then you're splitting into four parts. Uh, the second is to understand what these papers are. So, if you did you read the papers of VGG 16 versus ResNet to
Yes,
understand how
sir.
they are constructed?
Some basic knowledge I get from the both architecture,
Mm-hmm.
and of course
Yeah,
I think if I change the architecture, I need to also change the pooling size and all to reduce the gap between the graphs with less epochs accuracy. Like, of course, we can't run like 100, 200 epochs because we don't have enough time to guess the accuracy as well as. So,
exactly. Yeah,
like within 10 to 15 epochs, we have to get the much accuracy as well as possible, plus validation, and the
yeah,
graph may be much smoothing as well. Like it should be not much jittering over there.
yeah, yeah.
Yes.
Okay, so I think that's very good. And the other suggestion is, try to, as you go forward, normally a lot of researchers or engineers are stuck at the back end and doing all kinds of things. I also
Yes.
believe that, people using different architectures and also UI UX platforms, but also showing more metrics on the platform, right? If you say,
Mm.
oh, it's cancerous versus it's benign, it seems very, very binary way of saying. Doctors basically also say to you more things than just, oh, you have cancer or you don't. They'll say, hey, listen, it's a 79% accuracy here. So perhaps in the future projects, it's good to make your front end also a little bit more visual, a little bit
Yeah, sure.
more, showing more metrics, so people know that it's 89%
Mm.
accuracy, etc., etc. Those are the two
Mm.
suggestions, and of course, I think all in all, well done, very good. I think it's a very good first start towards your journey to become an AI engineer. The world is full of the needs, desperately needs smart people to participate in startups or scale ups or enterprises. No, I think it's a job well
Mm.
done. We are very happy to sort of share with you the certification and everything. We'll do our best from our side, Vishal, myself, Tanisha, to kind of promote your work, and so we'll do our best. I believe, Tanisha, you have some sort of things to share regarding certification, etc. And
Yeah,
we're
sure. I can show the certificate
very good.
that.
Well, good job, Tarandeep.
Yeah, thank you so much, sir, for appreciating me.
Okay, so,
Uh,
so that's Taran. That's your certificate of achievement. We will email it. We will email to you shortly, and this is the code through which you will be verified. So if you're showing this to anyone, that code verifies that you have done this project internship with us, and
yes, ma'am. Thank you so much, ma'am.
so I think that's mostly it for now.
Thank
Yes.